Welcome friends. Today's lecture we will have on the B-spline curve. Yesterday's in the yesterday class we have seen the Bezier curves. Now we will move towards the B-spline curve. So there is a very small difference between Bezier curve and the B-spline curve, because in the Bezier curve we are using the control points. Here we are also using the control points, but number of the control points are something variations here. So let us see here the B-spline curve. Here in this figure, as you shown the three figures, the first left figure is the Bezier curve with the degree of the 11, and in between it is difficult to the bend at the neck, means as shown in the first figure. So wherever the line is moving, in that segment we are setting the control points, that is P0 to P1, P2, P3, P4. So somewhat bends will be giving you the number of segments more, means the neck of that curve is indicating your number of control points will be the more towards in line segments. So that is in that figure the line segments, that is P4 and the P5 will showing you the very high line segments. So next, going to the next part, the middle figure above this is idea, that is a Bezier curve. So whereas in the middle figure that will be with the three joining points, that will be the with the three joining points is showing. In the right corner, that is also B-spline curve, that is the degree is will be defined as a 8 control points. Here in the last figure we are using the 8 control points, that is P1, P2, P3 up to P8. So this is what the difference between the Bezier curve and the B-spline curve. So in between the Bezier curve and the B-spline curve, the number of control points. So whereas in the Bezier curve, the neck point, means wherever the curving will be there, in that curving area we are very sure to create the control points. Means in the Bezier curve what we are doing is, in the Bezier curve we are creating the tangential line, we are creating the tangential line in the Bezier curve. So that tangential line will give you the line point, that is the control points from one position to the another position, that it may be P1 or P2. But whereas in the B-spline curve we can create any control points, so however the diagram is there. So this is what the simple difference between the Bezier curve and the B-spline curve. So in the B-spline curve, so those little dots subdivide the B-spline curve into a curve segments. So we can call it as a curve segments. Means whenever you are dividing, if the curve is very critical, if the curve is very critical or very lengthy, so then what we can do is we are going to subdivide the entire domain. So that will give you the small curve segments. So when you can move the control points here, we can move the control points for modifying the shape of the curve, just like what we do in the Bezier curve also. That Bezier curve also what we are doing, we are changing or we are modifying the curve according to our requirement. So whereas also here in the B-spline curve we are going to do, but the thing is what we are changing with the dividing, means we are changing means we are dividing the entire domain with a small segment. So here we can also modify the subdivision also, that is very important. Here we are going to modify the subdivision also. Subdivision is meant was, it is a part of the main domain, it is a part of the main domain, that is also we are going to divide. So that is also very important part in the B-spline curves. Are you getting your points? So whereas the little bit difference is in the Bezier curve and the B-spline curve, but in the B-spline curve we can subdivide the entire domain into small number of parts and we can create the control points, or called we can create the control points to create the diagram. So here subdividing the curve directly is difficult to do. Instead we subdivide the domain of the curve. Means as earlier I told you, means dividing the entire your curve, dividing the entire your curve, means entire curve is a very bigger part. So we can draw a simple curve or we can have the very critical curve also, but directly it is very difficult to show the control points. So at that time we are going to subdividing the curve directly but subdividing the domain of the curve. Domain is nothing but the entire thing. We are subdividing the entire domain with a small number of parts, then we are adding the control parts here. So here as shown in the figure, the domain of the curve is, that is 0 1. This closed interval subdivided points called as the nodes. These subdivided control points are called as the nodes. Here as shown in the figure below line, that is the nodes. So that is having the point that is 0 to 1, but that 0 to 1 will be continuously giving you the control points in the curve. That will be continuously giving you the control points in the curve. Are you getting my point? Okay. So as I told you, here the modifying the subdivision with the 0 to 1, change in the shape of the curve, because our line segment will be bigger one here. So according to that, you can change the segment. So in the total summary of this one, to design a B-spline curve, we need a set of control points. We need a set of control point, a set of nodes, and a set of coefficients. Means coefficients for one for each control point, so that all curve segments are joined together, satisfying certain continuity in the segment. Certain continuity in the segment. So as shown in the figure here, so if it is a curve that is from P0, P1, P2, P3, P4, P5, P6, and the coefficient, that is a T3, T4, T5, T6 and T7. So this indicates you the total simple difference, whereas in the B-spline as a Bezier, the simple difference is that, so here in the Bezier we are using the tangential of the curves. For that one we are giving the control points, whereas here, according to the requirement of the curve size, we are giving you the control points to draw the line segment in the curve section. So this is what called the B-spline Bezier curve. So we will see one more different Bezier curve here. The computation of the coefficient is perhaps the most complex steps, because they must ensure certain continuity conditions. So here in this curve, there should be a continuous conditional with that. As shown in here, the ensures certain continuity must be there. Certain continuity must there. Means as you are going to draw a curve segment, we should ensure that there will be a continuity in the segment. That is a curve segment. Then only we can have the control points to draw the line segment. Clear? So let us move the next part also in this one. So the degree of the B-spline polynomial can be set independently of the number of control points. Here the polynomial, the degree of B-spline polynomial can be set independently. Here there will be no any dependent upon the tangents of the curve, as in the previous lecture, that is in the Bezier curve. So we are doing with the line segment according to the tangential of the curve line. But whereas here in the B-spline, so the degree of this B-spline polynomial is continuously independent. Means then we can give you the number of the control points. We can set the number of the control points. Why? Because so if number of the control points is more, if the number of the control points is more, then it is very easy to locate the line segment. So that view allows you in the B-spline curve, but it is not considered in the Bezier curve. Bezier curve should undergo directly with the tangential line from the curve, wherever it may be, but we should go with the tangential line of the curve. Then only we can join the tangential lines continuously. Then that endpoints, every endpoints will give you the continued control points. But whereas in the B-spline, we can have the number of set of control points. The B-spline allow local control over the shape of the spline curve or the surface curve. So where it is very useful in the doing the surface diagram, surface design. So we have the CSG, that is concept to solid geometry, as we have discussed in the previous class. CSG also is there. Then diagram, simple line diagram is also there. Then surface design is also there. So whenever you are going with the surface design, you require these kind of the helpful, because this will give you the clearing the errors in the surface design, because surface designs have number of the control points. So according to that, you can have the Bezier or B-spline curves. This is what second advantage. So in the Bezier, but in the Bezier curve and in the B-spline curve, the two advantages I will show you here. So a B-spline curve that is defined by 6 control points and show the effect of varying the degree of the polynomial, that is 2, 3 and the 4. As shown in the figure, here, the degree of the polynomial, that is P2, P3 and P4. So in this one, the Q3, Q4 and Q5 will be defined with the control points. That is, suppose if you are going to take the curve as a Q3, as shown in the figure, so you are going to see the curve as a Q3. It will be defined by the P0, P1, P2 and P3. P0, P1, P2 and P3. So this will be the in the left side of the diagram, that is the Q3. So if you are going for the Q4, the same continuity in the continuity in the curve, that is the same thing will be defined by the P1, P2, P3 and P4. Here we are eliminating the P0. Why? Because this is somewhat further with the P1 part. This is starting little bit beyond the P0 point. So that's why we are not considering the P0 in the Q4 curve segment. But whereas in the Q5 is defined by P2, P3, P4 and P5. Q5 is here at this degree is the 2. So whereas in the degrees will be different here. So for the Q5 we are having the degree 2 degree, but here we are not considering the P0, P1, P0 and P1. Why? Because it is far away from the P0 and P1. So this line will be started with the previous line, that is called as a P2. So then it will be indicating the P2, P3, P4 and the P5. Means the same way the diagram is showing continuously, means your curve is showing continuously as shown in the figure. The curve is continuously, but whereas the Q3, Q4, Q5 are defined by 2 different control points. Means your control point will be vary according to your curve segment. Clear? So one more advantage, the effect of changing the position of control points. The effect of changing the position of the control point, so we can call it as a locality property. Here in the B-spline, this is very important thing. It is very important and very advantageous thing, that is locality property will give you the very effective changing the position of the curve. Very effective changing the position of the curve. Let us see here in this point P4, P1, P2, P3 and P4 point is there. So that P4 point will give you the 3 different control points, set of the control points. Means at the P4 we are changing the curve segment. Let us see here. So Q4 and the Q5 as shown in the diagram, Q4 and the Q5. So from Q4 we are changing the curve section. Let us see here. At the one thing will be going towards the first one and second one and the third curve section. So as compared here, the position of the P4 point 4 will give you the various positions in the B-spline. That P4 will be considering with the first curve, second curve as well as in the third curve also. In the 3 different curve sections also we are using the P4 point. That P4 point is called as a locality property. So this locality property will give you the very important changing mode in the B-spline curve. Clear? So here as shown in the figure, the Bezier curve and the B-spline curve. It's a very simple thing. You can understand here. In the Bezier curve, let us see here. In the Bezier curve, what? In the first diagram, T0 and the T1. T0 and the T1. The parameters, the endpoints of the curve is called as a T0 and T1. First is the initial T0. The first line that is from P1 to P2, that is tangential to the first point, that is the T0. So whereas in the second curve segment, so there also we are taking the tangential of line of the curve. So that is a P2 to and P2 to P4. But whereas in the last point, there also again we are having the continuous tangential line, that is a P4 to P3. So if we draw a line in between P2 and P3, if we draw a line in between P2 and P3, it will be continuous line, that is P1, P2, P3 and the P4. In the second diagram, the same thing, it is a continuous simple parabolic segment. Initial point we are having the tangential line, again the curve segment we are having the tangential line, and its end point we are also again having the tangential point. We are just adding the contour points directly with the line segment, that is a P1, P2, P3 and the P4. But here also the parameters, that is a T naught, T is equal to 0 and T is equal to 1, means your points, parameter points will be only 2, T is equal to 0 and T is equal to 1. In the every diagram we are having only T first point and the end point, we are having only the first point and the end point in between both the things, So in third diagram also we are having the P0, P1, P2, P3 and P4. Instead, if you are missing the P0, then we can directly start with the P1, no problem. P1, P2, P3 and the P4 points, the control points are same here. In all the diagrams we are using the same control points, P1, P2, P3 and P4. In the second diagram also we are using the P1, P2, P3, P4, and in third diagram also we are using the same control points, that is P1, P2, P3, P4. Whereas your set of the line segment will be having only different thing. Everywhere we are having the 4 lines, that is the line segments controlling. So this is the Bezier curve. So whereas in the B-spline curve, let us see here in the B-spline curve, the curve is very simple. But we have drawn number of points extra. But instead of that one, here also we are having the parameter T is equal to 0 and T is equal to 1. But the control points, that is P1, P2, P3, P4, same thing we have taken. But here there is a no tangential line together, this one. This is what somewhat difference between in the Bezier curve and the B-spline curve. Here in the B-spline curve we can have the number of control points, but here also we are use the same control points, that is P1, P2, P3 and the P4. But wherever and whenever you are doing the control points, means to showing the line segment of the through the control points, that should cover the entire curve. That is very important. You can have number of control points, no problem, but the thing is that should entirely cover the spline. That is very important. This will give you the difference between Bezier curve and the B-spline curve. Okay friends, this is I think so this is very clear with you, that is the difference between the Bezier curve and the B-spline curve. Okay, the further lecture will be in the next class. Thank you.